Okay, guys. So first of all, let me share my screen with you guys. Let's start slowly. Where is it? Where is syllabus and formula sheet? Yes. Can you see my screen? Can you see my screen? All of you?
Yes.
Yeah.
Good. Guys, I have one question. How many of you are taking this DFQ immediately after your Calc 2?
I am.
Yeah, because we are going to use Calc 2 a lot. I would say approximately 70-80% of your Calc 2 we are going to use over here in DFQ course. Usually the advisors, that's not your fault. Advisors, they usually advise the cadets to go for a sequence, Calc 1, Calc 2, Calc 3, but that's not the right sequence. What I prefer is to go for, those who took Calc 1, Calc 2 with me, they know this thing very well. That always try to sign up for DFQ immediately after your Calc 2 before you forget your Calc 2, right? Yeah, so don't make any kind of gap. So I think those who just finished your Calc 2, probably that's a good idea. And Calc 3, I think we are using hardly 10-15% of Calc 2 in Calc 3. So good sequence is Calc 1, Calc 2, DFQ, and Calc 3. That's what I think. And yeah, so anyway, now all you guys have signed up. So let's start with this one. Just look at over here. Yeah, it is kernel now. Okay. Don't look at this one. This is just the tentative syllabus. We are not concerned about this thing. The main thing is, of course, this is the spring semester. So don't look at even this one too, because the daily schedule I have not set up this one so far, but just we are going to use these many chapters. We are going to use the book of Dennis Zill. Nicely written book. I like this book. I think I have mentioned that thing over here. Yes. A first course in differential equation with modeling application by Dennis Zill, 10th edition. Nicely written book. Main thing is all the things written in this book that is in a very compact form. So,
all right, sorry about that. My
yes.
went out.
Please. Yeah, so that's why we are here. Book is really very good. Only thing is everything is really very compact form, but we are going to go over almost all the parts. We are going to finish the whole book almost, except few chapters, the whole book in next 5 weeks. So please make sure, if I'm teaching over here for at least 1.5 or 2 hours, please make sure you have to work at least 3 hours daily. You will be giving 2 assignments. The first one is number of problems from your book. And second one is your practice test. It's either one. Choice is yours. You can either go for the problems which I'm going to assign to you from the book. Second is a practice test. That is also a part of your book, because all the problems included in the practice test, they are from the book. But I have scrutinized so many examples over here in the practice test. So it's your choice. I am going to collect your homework. Yeah, we will be discussing about your homework and everything every day. But I'm not going to ask you the hard copy of the homework in every class. I'm going to ask you the hard copy on the day of the exam. Every after a week, we will be having one exam. This schedule says that we will be having 4 internals, 1 final. Weightage of each internal is 14%. Multiplied by 4 means 56%. Final weightage is 30%, so total 86. 14% last, that is for your homework, class participation. If I ask you some questions, if you answer that question correctly, nicely, politely, good attitude, everything counts. So that is your last 14%. Everything is mentioned over here in the schedule sheet. If you have any doubt, just try to go through this one, not right now after the class. Just try to go through this one. And if you have any doubt, you can ask me any question anytime. I don't mind to repeat the things 2, 3, 4 times. That's fine with me. Only thing is, I just want you to make sure about everything. I'm going to provide you probably after this one. Let me see. This is a summer course, and that's why, of course, we are going to follow the honor code. But if you want to have your drink, some stimulator drink, I mean to say, coffee, tea, juice, that's fine with me. I don't mind. But just try to pay your full attention. Try to be awake. Don't sleep in the class, please. Last information is you have to be well dressed up when you come to the class. I don't want to see you in some unusual dress. So please make sure I don't lie on the sofa or your bed. Sit properly, because that's a part of the VMI honor code for the summer. You can choose your dress. Yeah, you don't have to be in uniform. You know it. Even I'm not in the uniform. Yeah, because it's a summer. But you have to be well dressed up. So please make sure about this thing. These are the problems. Look at over here. These are the problems I have chosen from your book. So section 1.1, example 1 to 8, 10, 12, 14, 15, 17. Some few more problems are there. These are called the suggested problems. That's not mandatory. If you want to go through this problem, that would be sorry, that would be appreciated. Otherwise, you can go through the homework problems that is mandatory. But again, either one. These are the problems from your book. Simultaneously, I'm going to provide you the practice test assignment. Either you can go for this one, whatever you can see on your screen right now, or the practice test assignment you will be seeing probably very soon. Either one again, either one, right? So everything is mentioned over here. Here, the full set of problems are there, chapter 1, chapter 2, or test 1, test 2. Everything is mentioned very clearly. And if you have some doubts, you can ask me. Review for the final and everything. Yeah, in 5 weeks, we have to finish the whole book. So please, guys, if you are working, try to manage your time. I don't say that don't work, no. But I would just like to say you try to manage your time. I don't want to listen any kind of excuses. I'm sorry about this, but yeah, I don't want any excuses, please. How you manage your time? If you're working, if you're playing, if you're watching your TV, movies, that's your job. I just want my work. This is the first day instruction. That's the full and final instruction. I'm not going to repeat this thing again. This one is the formula sheet. Take the printout of this formula sheet. You will not be allowed to look at any kind of screens or online for the formulas. So you have to take the printout of the formula, this formula sheet. This is the integration derivative formula sheet which VMI guys have used for Calc 1, Calc 2, almost same formula sheet. But it is quite useful to us. One thing, within this course, I'm going to provide you a lot more formula sheets too, maybe 5, 6, 7 more formula sheets. And I will allow you to use all these formula sheets in your exam. Only thing is, in the final, suppose you have a bunch of formula sheets. And suppose you need to look at you need to find one of the formulae. You must know in which formula sheet that formula is given. Otherwise, you will be just wasting your time and you will be running out of time in the final. Don't do this thing. Only thing I would like to suggest you is, whenever I give any formula sheet to you, try to spend 10-15 minutes. Just look at the things. I don't want you to memorize things. Just look at the things, so that you will be having the idea that this formula is given in this way, this page, back side, first side, upper part, lower part. That will save your time a lot. Just the advice, if you want to follow it. Okay. Formula sheet. This is counted as your first formula sheet, right? Sorry. And everything is there on Canvas. Margie?
Yeah.
Are you able to open the VMI Canvas?
Yeah, I have the canvas. It just said that your class wasn't shown yet. I think
My
that
class? No, it is there.
Yeah, I
Um,
got the same thing, sir.
Like, it wasn't.
Are you sure?
Yeah, the class isn't showing up for me either.
Oh my gosh.
Yeah, that's why I
That's the
didn't know
same
when
for
we were
me,
meeting
too.
So
today.
that's why you won't be able to look at the things which are already submitted, which are already posted on Canvas, right?
No, sir. I
No.
can't see anything either.
Are you sure, guys?
Yeah, it says like it's enrolled, but
I
it's
never-
not like posted at all. I don't understand.
Yeah, it's not there, sir.
Can you please double check right now? Because I posted a few of the things just yesterday night, late night, 10:30. So can you please check?
I don't think you published your whole course.
No, it's just the file. I submitted everything in files. So it's automatically published. If it is announcement or some, yes. Nathan Light, are you getting it?
That's I don't have it.
You don't have it?
It says
Anyway, I'll make sure and I will, let me do it right now. Because I think, yeah, I don't want to give anything pending. So just give me some time. Let me do it right
Yeah.
now. Wait.
It just says it's published.
I just checked them out. I
Yes, I can't hear you. Who was there?
just,
Nina? Who was there?
yes, sir. Yes, sir.
So you got it or not? Are you getting it or not?
Yep.
No.
I don't have it, sir.
Okay. Let me double check, please. VMI, Canvas. What's going wrong? No, this is not what I'm looking for. Okay. My VMI and Canvas. And my course is 311. Oh, 311 is here. Okay. Oh, okay. Got it. Files. All the files are here. What's the problem now? And this one is published. Okay. And what's wrong with that? Okay. Unpublished course. I think VMI need to publish this course. This is called the unpublished course. Home and module and announcement. The module, no, we don't want to. Syllabus, edit. Files, pages. Let me submit something else and try. Let me try it again. All my files. Upload. Something is wrong. I can publish my first course, then why I can't publish your Diffie course? I don't know. Because VMI has not published that one so far, I think so. Okay. Course module, syllabus, chosen, published. And
Sir, it just popped up on my canvas. I refreshed my screen and
okay.
311 showed up. So I don't know
Other
if that
guys?
works for other people.
So are you able to see now all my 4 files, whatever I published
I saw it.
files?
Yep, I've got it, sir.
Margie?
Yeah, I can see it.
Okay. Sounds good.
Yeah, mine's good now.
Good.
Yep,
I got
yep.
it.
It's
Yeah,
out.
it is in the published list now. Yeah, it is in the published list. Yes. Sorry, guys. Okay. Okay, so this is the screen and we already discussed about this thing. Let me close this one. And one more thing, guys. Let me finish this one and screen sharing has stopped at the shared video. Okay, good. Now I want to share with you. This one. Can you see my screen? Can you see
Yes.
my screen? Okay.
Yes.
Look at here, guys. This is the practice test assignment for your first exam. Homework assignment, you can say. This is the, you can say, subset or subpart of your main assignment. But again, it is either one. Example number 1, you have to pick up like this. Exercise 1.1, example 1 to 8, order, degree, and linearity, verification. Third example, fourth example, fifth example, 6, 7, 8, 9, 10, 11. These are the examples you need to go through. I will try my best to help you out for at least 60-70% of the exam, at least 70%. So already you will be having 70% ready-made solution of your practice test. But you need to write it down by your own handwriting and you need to submit to me. If I solve the example over here, excuse me. If I solve, suppose one example over here, suppose example number 10.1, that doesn't mean that you don't have to write it down. No, you have to write down this one too. So if I take the same example here in the class, you have to repeat the same example, write it down by your own handwriting and submit to me on the exam day. This is the additional formula sheet. And sorry, not the formula sheet. We can say computational sheet. These are some integrations. Nick, what are you doing?
I have a second monitor set up. I have your screen share
Okay,
on my
got
side.
it. Okay. Compute the integral 1 over e to the power 2x. These are simple integrals. Some of the functions. These are based on Calc 2. Try to find the integrals of all these problems. Frequently, we will be using this type of integrals in our course. These are just some of them. But I just chose different types of integrals over here. So this is not mandatory. But if you submit this one, I would appreciate. So try to find this one. If you want, you can use, you don't need to write it down over here. You can use separate piece of paper, attach these pieces, all the papers, and submit to Canvas on the exam day. Or you can submit before that too, but exam day is good. Okay, some formulas. Introduction to differential equation. One more thing. I'm going to provide you the owner code statement. All of you, including Margie, all of you have to take the printout of those first 2 pages. Read each and every line and sign at the bottom. Sign at the bottom. That is called the owner code statement for VMI. and then give it to me, then send it to me. Right, guys? Most likely I will be providing you that owner code statement probably by the end of today or tomorrow, but I will give it to you very soon. Just remind me around after 1 hour, maybe today. Okay. The first, as I told you that I like this book. Why? That's the first question. Very rarely you can hear from me that I like some book. Yeah, sometimes, always I'm finding some drawback, something missing, some kind of things. But I like this book. Yes. The reason is, author has not mentioned anything. But if you read the book, you will realize this thing. That book is divided into 3 parts. So in short, I would say that our syllabus is divided into 3 parts. 3 parts, I mean to say that the first part is first order, first degree differential equation. So first part is, look at here, just the introduction. But introduction of first order, first degree differential equation. I will let you know what we mean by degree, linearity, all these things. Just wait. First order, first degree differential equation. Introduction. Introduction includes only what we mean by differential equation, what's the solution of the differential equation, what we mean by the initial value problem, the boundary value problem, and then after the superposition principles, and then after the uniqueness of the existence of the differential equation, uniqueness of the solution of the existence of the differential equation. These type of things we are going to see in the introduction portion, but we are not going to solve any differential equation in introduction. Verification is there in the introduction. Verification means differential equation will be provided to you with the solution, and we are going to verify whether the given solution is actually a solution of the given differential equation or not. That is called the verification. Higher order differential equation, all these things we are going to see. Physical interpretation of the differential equation, all these things are included in the verification, in the introduction portion. Then after in chapter 2, we are going to solve actually the differential equation of first order, first degree. First order, first degree differential equation I divided into 6-7 different parts. Try to look at me, please. 6-7 different parts. The first one is separable variable. Second one is linear differential equation. Third one is non-linear differential equation. That is called Bernoulli differential equation 2. Fourth one is exact differential equation. Exact differential equation are divided into 3 subparts. 3 subparts. We will take care of that part probably after a week or after 4 or 5 days. Then after, homogeneous differential equation. Then after, solvable, U substitution for the differential equation. Then after, solvable the differential equation by P, X, and Y. But this solvable by P, solvable by X, solvable by Y, all these 3 parts are not there in your syllabus. So we skip these last 3 parts, but first 5-6 parts are there. First 6 parts are there for first order, first degree differential equation. That is your chapter 2. Chapter 3. Now we are done with first order, first degree differential equation. Chapter 3, that is nothing but the application of differential equation, first order, first degree only. And we are going to see several applications, different kind of applications where first order, first degree initial value problem differential equations are involved. Practical problems, chemical problems, electrical problems, chemical reactions, different kind of problems are there. And I will let you know everything time to time. I found that particularly for VMI, at VMI, because I taught at several universities over here in the United States, Mary Baldwin, James Madison University, VMI. And I found one common thing, that people are afraid of applications. And that's what I did. I prepared one packet for you. And that packet is already posted over there. So before we started, I just want you to take the printout of that packet. Once you have that packet, then after we'll start to solve each and every, almost all equations, not all, but almost all problems given in the packet. And I will be asking you, you will be asked almost same kind of problems in the exam. And I have covered all different types of problems in your packet. That is for chapter 3. One phase is over now. Part 1 of your course is over. Second part, chapter number 4, completely based on higher order differential equation. Means higher, I mean to say that second and higher order differential equation, not first order. Second and higher order, but degree 1. Order is different, higher, 2 and more. Again, chapter 4 starts with article 4.1, introduction, just like your first phase for first order, first degree. Higher order, introduction. Then article 4.2, second order differential equation. That means you will be having 2 solutions. Out of these 2 solutions, one solution will be provided to you, and we will be looking for just the second solution. That is called reduction formula. Article 4.3, now higher order differential equation technique is completely different from your first order, first degree. It has no relation. Yep. Higher order differential equation are divided into 2 parts. Try to listen to me very carefully, guys. Please. The first part is homogeneous differential equation. Homogeneous, I mean to say that your right hand side equal to 0. Non-homogeneous means right hand side is some non-zero functions. Maybe just one function, or maybe combination of 2, 3, 4 functions. Maybe exponential function with trig functions with algebraic function with some exponential function, some combination, some hyperbolic function, etc. If you are asked to solve non-homogeneous problem, be careful. First of all, you have to assume that your right hand side is 0, means convert your equation to just homogeneous, solve it. Using that solution, go for the non-homogeneous part, means right hand side non-zero. That is completely your article 4.3 and 4. 4.3 is homogeneous, 4.4 is non-homogeneous. 4.5 is not there in the syllabus. 4.6, method of variation of parameter. If you refer the book, he has used, on all the authors, they have used a long formula. I don't like that formula. And that's why I developed one formula before a few years. And we are going to use that formula. If you use my formula, you will be getting the answer just in maximum 3 or 4 steps. If you use the formula given in the book, you are going to use at least 1.5 or 2 pages. Choice is yours. I don't mind. But I verified this thing for more than 50 examples or 100 examples. We are getting the same answer if you are using my formula. Sounds good? And that is valid formula too. Nobody claim or nobody can take the objection that my formula is no. It's a valid formula. You will be getting the same answer. Then after article 4.8, simultaneous linear equations. I'm not going to solve just one differential equation now, but we will be solving couple equations, 2, 3, 4 equations simultaneously. That is called simultaneous linear equations. And your second test will be, third test will be completely based on chapter 4. That's it. Your last test, that is chapter 5, 7 and 8. 5, 8 and 7, I would say. Yes, I want to break the chain. Chapter 5 is now application of higher order differential equation, and your phase 2 is over. Chapter 8 is now system of differential equation. We are not going to solve just one differential equation, 2, 3, 4 differential equations simultaneously. And whenever we are solving the system of equation, we only rely on matrices. That's the best source to solve the differential equations, right? Matrices. Yes, and we are taking help of calculators too. Okay. And chapter 7, phase 2 is over now. Phase 2 is over. Higher order, simultaneous linear equations, and system of equations. So chapter 4, 5, and 8, that's why I would like to consider 8 immediately after chapter 5, not 7. Chapter 7 is completely independent of your book, of your course. That is called Laplace transform. but it is equally important. I would say more important, because most of the engineering science problems, people don't want to use the techniques which we are going to use in chapter 4. People want to use the Laplace transform, because all practical problems, they are almost initial value problem or boundary value problem, initial value problem. And that's why Laplace transform is the best tool to answer, to get the answer of those questions, of those equations, right? And that is the last part. And that's the end of your syllabus. Lots of things we are going to cover, guys. Lots of things. Don't take it easily. Yep. Again, if you think you are the best judge of yourself, if you think that you are not good at Calc 2, still you have time. Revise your Calc 2 notes, whatever material you have. Couple of our faculties and I wrote down one book, that is Apex Calculus, Calc 1, 2, 3 book. Pick Calc 2, it's online via my website. Try to refer the books, not the whole book. Try to refer just Calc 2 book, chapter number 6, mainly chapter 6. Different techniques of integration. Try to go through that chapter thoroughly. Yes, use YouTube videos, blah, 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 whatever material you are having. But I want you guys not to disappoint me. I want you guys to answer my questions if I ask you anything based on Calc 2. Yes, this is just the beginning, and I'm informing you well in advance so that you can't blame me in the future. Any question? Any question? Sounds good. Okay, guys, so let's start the syllabus slowly. Okay? Happy? Say something. I said, please say something. Shall we start the syllabus? Oh my gosh.
Let's do it, sir.
Thank you. Okay, so first order, first degree differential equation. I just introduction portion, I wrote it down, whatever I explained to you. Always keep in mind this thing. I wrote it down different chapters over here. Already I explained. When y equal to f of x, function of one variable, we will be dealing with function of one variable. Function of several variables, you will be dealing with your Calc 3. Different course, not my part. I'm sorry, guys. Sorry. Okay. So y is equal to fx. Whenever you are writing x, see, I said that this is a function of one variable. Function of one variable, I mean to say that function of one independent variable, because function is always identified by its independent variable. As for example, suppose I write y equal to x square. Y equal to x square means you are allowed to choose different values of x. Y equal to x square will give you a parabola, right? So if I take, suppose x equal to 1. So y equal to 1, x equal to negative 1. Again y equal to 1, because y equal to x square. Y x equal to 2, y equal to 4, x equal to negative 2, y equal to 4, right? So if you choose these points, you are going to get, oh my gosh, where are my pages? Okay, let me, my pages. Okay. Y equal to x square, x equal to 1, negative 1, 2, negative 2, like this. You are going to get like this. Look at here. X equal to 0, x equal to 1 here, negative 1 here, x equal to 2 means 4 here, negative 2, again 4, 3, 9, negative 9. If you join these points, you're going to get the parabola. You get the parabola like this. Make sense? So that means the choice of x is independent. Whatever you want to choose, you are free to choose it. But y depends on x. If you are choosing x equal to suppose 3, and if you say that my y is 5, no, it's not going to happen. Because now your y depends on x. Once you choose your x, your power is off. You're done. You can't do anything more than that. So y equal to x square and x is suppose 3, your y has to be 9. You don't have any other choice because your y depends on x. X is the independent variable. So whenever I write dy by dx, y is a dependent variable, x is the independent variable. Always keep in mind this thing. And function is always identified by is independent variable. And that's why I would say that y equal to fx is a function of one variable. It is to be understood that one independent variable. Always keep this thing in mind. Okay. D square y over dx square plus 5 dy by dx cube equal to e to the power x. Now I would like to explain to you what we mean by the order of the differential equation. Differential equation, first of all, the definition. Differential equation means equation which contains a derivative differential equation which contains a derivative with some integer power. That is called the differential equation. So equation which contains the derivative is called the differential equation. You can see over here, this equation involves derivative, second order derivative, first order derivative, power means degree 3. Order of the differential equation. Order of the differential equation means highest derivative occurs in the differential equation. Look at over here. What is the highest derivative here? 1. What is the derivative here? 2. What is the highest derivative in this equation? I'm asking you guys.
2.
2. So what is the order of this differential equation?
Second order.
Second order. You got it. So order means highest derivative involves in the differential equation, that is called the order. And all of you, please look at me. And power of the highest derivative is your degree. Power of the highest derivative is degree. What is the power over here?
1.
No, power 3. But order was power of the highest derivative. Power of the order is the degree. Order is 2. Its power is 1, so degree is 1. Don't say that degree is 3, please. Degree is 1. Getting me? Yes or no, guys?
Yes, sir.
Yes.
Okay, so that's what we mean by the degree and order of the differential equation. Whenever you write degree, there is some restriction. Whenever you write degree, make sure that your degree is free from radicals and fractions or some square root signs. So it should not be, the degree should not be like this, root 3, d square y or dx square to the power root 3 or 1 by 2 or 1.3 d square dx square to the power 1.5. No, no radicals, no fraction, no square roots. It has to be simple positive integers.
Sir, just to clarify, that's a second order first degree differential equation, correct?
Yes.
Okay.
Okay, guys. So that's what we mean by the first order, first degree differential. My bad. Second order, first degree differential equation, order and degree of the differential equation. Any doubt so far?
No, sir.
Girls,
Can you explain why it's on first degree again? Because you said the exponent is 1.
order is highest derivative. Power of the highest derivative is degree.
Okay.
It is okay. Girls, Nina. Nina.
Yes, sir.
Rodriguez.
Yes, sir.
What are you doing? Where are you?
Taking notes, sir.
Oh, you are in the car. Oh, okay.
Yeah, I'm taking notes.
So where are you, right? I mean, say, where do you live?
I live in New Jersey, sir.
So you are driving from New Jersey to Harrisonburg, or I mean, say, Lexington?
Yes, sir.
Oh my gosh. Sorry. You should have driven to yesterday, right? Why today?
I'm sorry?
You should have you should have gone over there to yesterday. Why today?
Today was the only day that was available to come down. Yesterday was all filled up.
Oh, okay. Okay, good. Margie?
Yeah, I get that.
Good. Now, the second part is symbolical form of differential equation. Now, we are just talking about general order, nth order differential equation, and maybe an integer, as I told you, positive integer, 1, 2, 3, 4, 5, 6, 7, whatever it may be, right? Nth order differential equation is denoted as f of x, y, y dash, y double dash, y triple dash, y to the power n equal to 0. This is called the symbolical form. And the normal form of this nth order differential equation is given in this way. E to the power n y over dx to the power n is equal to f of x, y, y dash, y to the power n minus 1. One power less, please. Total n powers are there. See, y to the power y to the power 1, 2, 3 up to n minus 1 and one more y. So total n powers are there. And that's why it is d to the power n over dx to the power n. D to the power n over dx to the power. This is called the normal form. Suppose we are given one equation. Here f is any real valued function. 4x y dash plus y equal to x. So what is the normal form? Normal form means you have to write this y dash form, means dy by dx form. So divide throughout by 4x. If you divide throughout by 4x, so y dash equal to dy by dx. Dy by dx. This x, take this y other side, so x minus y divided by 4x. So x minus y divided by 4x. Now this is my normal form. This is my normal form. Agree? This one is my normal form. Okay. Second part, linearity. I will be using this definition so many times, at least 5 to 7 times, at least 10 times in the course. And that's why I want all you guys to memorize this definition. Please. Linearity. A differential equation is said to be linear if two conditions are satisfied. The first condition is if dependent variable, what is dependent variable in dy dx? Dy dx, what is dependent variable, Margie?
Yeah.
I want the answer, please.
Sorry, I got up and got paper.
My question is, if you have dy over dx, what is the dependent variable? I already explained to you. Rodriguez?
The dependent variable, would it be y?
Y. And y depends on x, right? Y equal to fx. Is it okay, Margie?
Yeah.
Right? So dependent variable y and all its derivatives means y dash, y double dash, y triple dash, y to the power 4, blah, 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 and so on. So dependent variable and all its derivatives appear in a first degree. Means you cannot find, see y dash, y double dash, y triple dash, whole to the power 1. It has to be whole to the power just 1. It should not be 2, 3, 4. No, just 1 for the linearity. So y dash, whenever in your equation y appears or y dash appears or y double dash, y triple dash, whatever is dependent variable and its derivative appear, its power, their power must be just 1. That's my first condition. And the second condition, there should not be any kind of multiplication of these dependent variables and with its derivatives. Means you cannot find y multiplied by y dash, y multiplied by y double dash, or y dash multiplied by y double dash. No multiplication of dependent variable with its derivatives allowed. If these two conditions are satisfied, in that case, our equation is said to be a linear differential equation. Are you getting me, guys? Are you getting me or not?
Yes.
Don't disappoint me, guys. I told you so many times, if you are not getting any of the things, that is your right to stop me, and I don't mind to repeat the things 2, 3, 4 times. But if I ask you the question, I'm expecting the answer from you guys, please. Otherwise, you please ask me the question. I don't mind. Once you have signed, I didn't invite you, but you sign up this course, that's your choice. But now you are with me and you have to follow my instructions. I hope you agree with me. Am I right?
Yes, sir.
Suppose I
Yes,
am
sir.
not strict and suppose I am very liberal, and if I don't care of you guys, if I don't take care of your grades, do you think that I will be the loser? No. I am doing for yours, for your parents. It's hard for them to make finance for you guys. I'm worried about them. And that's why I'm a little strict to you guys, because I just want you to perform well. I just want you to give your best. Make sense?
Yes, sir.
Yes, sir.
Suppose you are getting A plus. Am I going to gain anything? No. I'm just doing my job. It's a part of my job. That's it. And you won't realize this thing until you will become a parent. You will realize this thing after 20 years, probably. When your child or children will be there in the college and you have to pay for them, to manage finance for them. It's not that easy. So respect your parents. And only way to respect them is just to work hard, take good grades. And that's the best reward for them and for yourself too. Right? Anyway, that's not my part to advise you. Let me continue with my syllabus, but please keep in mind this thing. If you have some doubt, you are most welcome to ask me. Otherwise, if I ask you, I want the answer. Sorry. Next. So two conditions are there. One is dependent variables and all its derivatives like y dash, y double dash, y triple dash, so on, must appear in first degree and they are not multiplied together. If these two conditions are satisfied, then we can say that differential equation is linear. I like this course, guys. You won't believe, but I don't need any kind of material. I can speak for continuously for 35, 40 hours continuously without looking at any of the materials. And I can start the syllabus and I can finish the syllabus. Yes, I like this course. This is one of the favorite courses. Yeah. Whatever screen I'm sharing with you, that is just for your convenience. I don't want it. I know the problems given in the book, which corner or which page, I know everything. I don't say everything, but I know most of the things as far as comes of this course. And if you work with me, you will be probably like me by the end of this course, right? Anyway, the general form of the linear differential equation is dy by dx plus dy equal to q. You can see over here, dy by dx means my y dash, and here it is my y. Dependent variable is y, and its derivative is y dash, but in between there is a plus sign. So there is no multiplication, means my second condition verified. Am I right? My second condition satisfied.
Yes.
The dependent variable and all its derivative. Can you see dy by dx? Nothing is mentioned, means bracket to the power 1. Agree? And power 1. Agree? Means dy by dx and y derivative, dependent variable and its derivative, them both are in first degree. Agree? Because powers are just 1. Agree? Means first condition satisfied. That means this is my linear differential. This is called the standard formation of the linear differential equation. We are going to see the same thing, same kind of equation in our article 2.3, linear differential equation. Next chapter. Not right now, but very frequently I'll be using this thing. So please keep in mind this thing. If I write my P and Q, what is my P and Q? My P and Q must be a function of my independent variable, must be a function of X. If differential equation is given to you in the form of, listen to me carefully, form of dx by dy plus px, whatever y I'm having here, I have to have some y, same y over here. This y and y. If I have y here and here x, no, that's not allowed for linearity. You have to have y. And that's why I told you this is the formation. This is the formation. This P and Q must be a function of X, independent variable. I can write dy by dx plus 3y, constants are allowed, 3y equal to x square. Fine, it's a linear. Because dy by dx plus 3 is constant, is a function of x. X only or constant, look at here. is equal to 5, linear. dy by dx plus x times y equal to x cube, linear. Are you getting me?
Yes, sir.
Yes, sir.
Sir.
Are you guys okay? Good. Right? dy by dx plus x square y equal to sine x, linear. Agree?
Yes, sir.
Good. You know, in your assignment practice test, very first example was example 1 to 8 from your book, article exercise 1.1. Do you realize? Do you remember that thing? Very first line of your practice test. You
Yes, sir.
test on your canvas. Right? Very first line of your practice test was example 1 to 8 of your exercise number 1.1. Agree? And that is nothing but this one. These are the problems. Now, I don't want this thing. Oh my gosh, I don't have it. Here I gave you the answer. I don't want to give the answer. How can I close this one? I don't know. Anyway, answers are, I didn't want to give you the answer. So these are the example 1 to 8 from your exercise 1.1. I don't want you to teach the complete article or the chapter and then after we can go for the examples. No, my technique is different. If I finish one portion of the article, I would like to switch over. I would like to go for the examples, unsolved examples, exercise examples. So that you can compare the things, whatever you have learned and how it could be applicable to your exercise problems, unsolved problems, right? That's the best way of learning the things, in my opinion. Anyway, first one, 1 minus x y double dash minus 4xy dash plus 5y equal to cosine x. What is the order? Don't look at the answer, guys. Be honest to yourself. What is the order? Highest derivative is 2.
Second one.
Here it is 1. Here it is nothing is mentioned. So highest derivative is 2. And what is the power of the highest derivative?
It's 1.
So order is 2. Degree
2. Is 1.
1. Agree? Order is
Yes.
degree is 1. What can you say about the linearity? 2 conditions. Y and y dash should not multiply together. Y double dash is there, but there is no any other y or y dash, y double dash here. Y dash is there without any other y's. Y is there without any other y or derivatives. Derivative of y. Right? So, second condition satisfied. First condition, y and y dash. Y dash, what is the power of y dash? Order is 1. I mean, say derivative is 1. Power is just 1. So y dash dash power 1. Y to the power 1. Y double dash to the power 1. Can you see my y double dash, y, all dependent variables and its derivatives appear only in first degree?
Yes.
Look at my cursor simultaneously. 1, 1, 1, right? Don't consider this y, this one. This is y dash dy dx, but dy dx to the power 1. So degree is 1. First condition satisfied. And that's why this equation is a linear differential equation. Agree?
Yes, sir.
Any doubt? Any doubt? Good. Let's go for Campbell. Explain me. Second one. Don't look at the answer. If you already looked at the answer, explain to me why it is order this one, degree this one, linear or not.
I haven't looked at the answer yet, sir.
That sounds good.
So on the first term there, the degree of the differential is it's third degree, and the second differential is first degree.
Wait. Not degree, order.
Order. That's yes, sir.
Right.
The order
Order means highest derivative. Just speak like this. Order means highest derivative. Highest derivative is 3. So
Yes,
order is 3. Makes sense?
Yes, sir.
And power of the highest derivative is a degree. Here it is 1. So degree is 1.
Yes, sir.
Sense? Makes
Yes,
sense. So don't count this 4, please. And y triple dash is there, y cube, y to the power 1, first derivative, and y. They are not multiplied together. So it is linear. Agree?
No, sir.
No, good. Why not?
Because the
Second condition.
right,
Yeah,
the
first
second-
condition.
the first condition is not satisfied.
Why?
because the first order derivative is raised to the power of 4.
Correct. For linearity, it has to be 1. Agree?
Yes, sir.
All of you agree with me or not? All 10 guys? 9 guys, sorry.
Yes, I agree.
Yes, sir.
Tyson?
Yes.
Margie?
Yeah, so it has to be raised to 1 to be linear, right?
Yes. Yes, but it is 4. That's why this creates the non-linearity. Make sense? Margie, I'm asking you. Make sense?
Yeah, it makes sense.
Okay. So it is not linear, right? Look at here. Okay. Rodriguez. No, Rodriguez is driving. Let me skip her. Rodriguez, are you getting us?
Yes, sir.
Okay. Okay, today I don't want to ask you any more questions because I'm getting some voice from your car. So I don't want other guys to be disturbed.
Yes, sir.
Yeah, that's fine. You just pay attention. And Margie, would you like to take the third one?
Yeah.
Go ahead.
I'm having trouble reading. What?
Reading? Yeah, it is
Well-
4 here. It is 4 here.
Okay. Okay.
And one more thing, Gargi. Let me help you.
Yeah.
Here, see, previously it was mentioned x here.
Mhm.
And these x and x were same, means independent variable. Here it is mentioned t, means your independent variable is t. That means your this y double dash, it means that d square y over dt square, not dx. Okay? Are you getting me?
Yeah.
Okay. So instead of x, you can count t in this equation. Okay? That's the only difference. Go ahead.
Usually you would look at the order it's raised to.
What do you mean by the order?
Because for the other two, it was like the second derivative. So, the order was 2.
Second derivative, that's the highest derivative.
Yeah, yeah.
2, so order is 2. You are absolutely right.
And then it's raised to the power of 1, so the degree is 1.
Correct. Linearity.
And the y is raised to the power of 4, so it's not linear.
Correct. You got it. Here y to the power 1, here y double dash to the power 1, but here y raised to the power 4. That creates the non-linearity.
Yeah, I think it was just confusing with the t because I was used to the x, but yeah, that makes sense.
I got you before you asked me this thing, and that's why I explained to you before you started. Okay? That t is nothing but just your x. Make sense?
Yeah.
Good. Okay, guys. Fourth one is a nice one. Who wants to take this one? Any other guy, please? Take the initiative.
I can do it.
Go ahead.
All right. So the highest order that's in there is 2 on the far left of the equation.
Hmm?
That's the highest derivative that's within it, and
Mhm.
since it's not raised to any power, it's just a
Means
degree.
1. Yeah, means 1. So order is 2, degree is 1. Then
And I'm trying to figure out where the non-linearity comes in.
good.
Because, yeah, this one's definitely a different structure than the other
Yeah,
equation.
it is. It is.
What
Look at here.
is that cosine on the right side?
Cosine alpha, yeah, cosine bracket.
Yeah. So
Yep.
cosine produces a non-linear, I guess, graph. So would that be what makes it?
No, actually look at over here. Not your fault, not your fault. You are just, this is first time for you.
Yeah.
Cosine produces,
It's been like 2-3 years.
that's I would say it's not the complete answer. See, first of all, my u's d square u means u double dash. U dash.
Oh, look,
They are not multiplied together, right? And powers are same, 1, 1, 1. So looks like our both the conditions are satisfied on left side.
Yeah.
Right side. What is my standard formation of linear equation? My q, p and q must be a function of x or constant. If you use the formula sheet, second page, middle part, unit circle, right side. Formula sheet, I just gave it to you. Second page, first page, turnover, second page, middle part, unit circle, right side. One of the formulae is sin x plus y equal to sin x cosine y plus cosine x sin y. Cosine x plus y is cosine x cosine y minus sin x sin y. I use that formula over here. Right? This is my q. My q must be a function of independent variable. Independent variable is r. Agree? But can you see my q here involves or includes my dependent variable u. That creates the non-linearity. Does it make sense?
Yeah, that makes sense.
Sure, Will? You got it?
Yes, sir.
Campbell?
Yes, sir. That makes a lot more sense now.
Rodriguez?
Yeah, I got it.
Rodriguez,
Yes, sir.
you got it?
Yes, sir. I got it.
Margie, are you okay?
Yeah, I got it.
Okay. Any other guy? I think all you guys are good, right?
Yes, sir.
Good. Tyson, yeah.
Yeah, all good.
Let's go for the next one. Rodriguez, would you like to take one? We are here to help you out. Number 5. Just look at this equation. Don't look at anything else. D square y by dx square equal to square root of 1 plus dy by dx whole square. What is the order? Somebody wants to help her?
2.
Yeah. Will, Tyson?
Since would your order be 2 because the derivative on the left side of the equation is well the
I
differential
said just
there is
pay
2.
attention here. Yeah. So derivative of the
right.
left side is highest derivative. Order is 2. Agree. Then
Order is 2. Okay. And then degree would be 1 because or no. Would degree be 2 because on the right side? No, it's 1. It's 1.
Wouldn't you move the square root over to the left because you wouldn't want to square root?
correct. Tyson, you are wrong.
Yeah.
See, I told you differential equation must be free from radicals of fraction. Here is a square root sign. Fraction is there. You have to first remove this fraction. That means you have to square both the sides to remove this fraction. So d square by dx square whole square equal to 1 plus dy by dx whole square. Right? Now it is free from radicals of fraction or square roots. That means now I can measure, I can go for my order, degree, and linearity for this equation, which is equivalent to this one. My order is 2, degree is 2, linear or not? Linear or not? Oh my God.
I don't think it's linear because don't you have
power is 2,
y
right?
as a
Power is 2
function.
and power is 2. So
Right,
that's the non-linear. Right?
Mhm.
All of you are getting me or not?
Yes,
So
sir.
since it was under a square root, you had to multiply it all by an exponent of 2.
You
But
have
then the
to,
dy over dy.
yeah, you have
wasn't
to take the
affected.
square root. You have to take the square both sides to remove the square root. Because again, look at here. Differential equation, whenever you measure order and degree, it should be free from radicals and fractions and square roots. Clear?
Yeah, it's just the dy over dx already had an exponent of 2 and then nothing was added on. So just wondering that's left untouched, right?
This one? Yeah, because if you want to remove this one, you cannot remove just blindly, right? You have to take the square on both the sides to remove this one.
Yeah, no, I mean the dy over dx that's under the radical.
dy, under the radical. Oh, yeah, right. So it's now out of radical, out of fraction, square root sign. So now it is order is 2, degree is 2, and because it's not linear, because of this 2. Agree?
Mm-hmm.
Good. Next one, d square r by dt square equal to negative k over r square. Just look at this circle, this equation. D square r by dt square equal to negative k over r square. What can you say about this?
Well, it's a fraction.
A. Yes. Any other guy?
Would the order be 2?
Order is 2. Okay. Degrees.
Is the degree 1?
Okay. Linearity.
It's not linear because it's multiplied.
What is multiplied? What is multiplied?
R squared.
To isolate Q, don't you have to
A,
multiply?
you have to have either independent variable, that is t over here, or some constant. I don't have any t here. I do have constant, but I don't have any t here. But I have dependent variable, which is not allowed. So let me send this dependent variable to the other side. So r square d square r by dt square equal to negative, right? And now you can see over here, my r is the dependent variable and its derivative, they are multiplied together. First condition violates. It's non-linear. Agree?
Yes, sir.
Girls?
Yes.
Girls?
Yes, sir.
Okay. Last one. Last or second last? Oop. Last one. What can you say about these guys? It's very simple, right? X double dot means d square x by dt square or dy square. X is your here dependent and d t or y is independent. Different notation for differential equation. X double dot to the power 1. 1 minus x dot square 3, x dot plus x equal to 0. D square x by dt square. Highest derivative is 2, order is 2. Power is 1, degree is 1. Because x dot square is there, it's x dot and this one, they are multiplied, non-linear. Agree?
Yes, sir.
Yes, sir.
Margie, clear?
Yeah.
Good.
Sir.
Okay, let's move to the next part, guys. Solution of the differential equation. Solution of the differential equation, that means a function which satisfies the given differential equation and does not involve any derivative. Because you are looking for the solution of a differential equation. Differential equation solution, that means d square y, or so dy by dx plus 2y equal to 3. Then you are looking for y, means you want to remove that derivative part. That means it has to be free from derivative. Right? So solution of the differential equation means whatever the function you are getting at the bottom, at the end of your solution, that must satisfy the given differential equation. You could plug it back. Suppose I give you the example, dy by dx plus 2y equal to 3. And suppose I say that y equal to e to the power 2x, suppose, is the solution, suppose. That means if you replace this y equal to about 2x in your left side and right side of the equation, that must be equal. It means it is the that is called that solution must satisfy the given differential equation. And this solution should not involve any kind of derivative. That is called the solution of the differential equation. Make sense?
Yes, sir.
Let me take the verification of this problem. dy by dx equal to xy to the power half, y equal to 1/16 x to the power 4. This is my differential equation, and this is my solution. I want to verify whether this one is a solution or not. How can I verify? This is dy by dx. I put the circle over here. Let me plug this value. This is my function, my solution. Let me plug this value over here. So I'm working with left-hand side. Then after I'll be working with the right-hand side. Paul Mustaine, are you getting me? Paul.
Yes.
Paul.
I was going back on the I'm trying to figure out what you wrote. Like, does it say FOG to the power n?
FOG? Where?
Like, scroll up a little and you'll see like
This one?
definition.
This one?
No, it's on the other page. I was trying to figure out what that said.
Other page? Which one?
It's like right what we wrote the definition.
Definition?
Yes, it's like now it's down a little bit more.
Nail down. Okay. Here?
Yes. What is this?
Oh, I'm sorry. This is called, I'm sorry. Solution, S-O-L and N. Solution, S-O-L and N. I'm sorry. I didn't write the whole one.
Thank you.
Equation which satisfies the given differential equation d dot e dot and does not involve any derivative is called a solution of ordinary differential equation, ODE.
Thank you.
Okay. So d by dx of y. Replace this y by the solution. D by dx 1/16 x to the power 4. 1/16 constant, pull it out. X to the power 4 derivative is 4x cubed. 4 will get cancelled out, so 1/4 x cubed. X cubed by 4 is your left hand side. Right hand side. X y to the power half. X as it is. Y is 1/16 x to the power 4 to the power half. Square root of 1/16 is 1/4. Square is 4th is 2. X and x square is x cubed by 4. X cubed by 4. I am getting left hand side equal to right hand side. That means this one is a solution of differential equation, given differential equation. And this equation is not involving any derivative. So this is a solution. Left hand side, right hand side, it's a solution. Makes sense?
Yes, sir.
Any doubt so far? Any doubt? Any doubt?
Nope.
Okay. Family of solutions. Family of solutions. Whenever you solve differential equation means you are not getting just one solution, you are getting number of solutions, family of solutions. Why? Because suppose I have one equation y dash equal to 2x. Or I can say y square, y equal to x square. Let me write like this, y equal to x square. Yep. I noticed where is my pen? Y equal to x square. Okay. Now, what's going on? Okay. So y dash equal to 2x. Y dash equal to 2x. Right? Derivative. If I go for the integration, if I want to remove this derivative, means I have to go for the integration, antiderivative. So if I, because antiderivative, integration and derivative, they are the reverse process of each other. Antiderivative cancels derivative, right? And that's why it is called antiderivative. So 2 derivative of x is, integration of x is x square by 2. 2 will get cancelled out plus c. So we are getting y equal to x square plus c. I started with y equal to x square. I'm getting y equal to x square. If I take c equal to 0, this is my parabola. This is my parabola. Look at my circle. This is the parabola passing through 0. If I take suppose c equal to 1, y square plus 1, this is the parabola. If I take c equal to 2, this is the parabola. If I take c equal to -1, passing through -1, this is the parabola. So whenever you are solving the differential equation at that time, solution will provide you the family of, you are going to get the family of solutions, not just one solution, right? So number of solutions are there for the given differential equation. Naturally, whenever once we have a number of solutions, then question must arise, what is the guarantee of the uniqueness of the solution? Is there any way that we can get just the unique solution of the given differential equation? Yes, answer is yes. We are going to see this thing probably after some time or probably tomorrow. Verification, example number 1, this whatever I solved over here, this example, this 1 to 7, this was your example 1. Now let's go for example number verification, that is your example 2. Let's go for example number 3 now in your practice test. Example 3, x equal to c1 cosine 40, y equal to c2 sine 40. C1, C2 are constants, all, this is just constants, okay? Are both solution of this differential equation, x double dash plus 16x equal to 0. Because I have second order, please keep in mind this thing. That's why I gave you 2 solutions. Means number of or order of differential equation must be equal to number of solutions. First order, 1 solution. Second order, 2 solutions. Third order, 3 solutions, and so on. Keep in mind this thing. Order of differential equation must be equal to number of solutions. Number of solutions. Good. I want to verify this thing. This is a differential equation and these 2 are the solutions. So let me start with the first one. So my x is c1 cosine 40. I want highest derivative 2. Let me go up to second derivatives. So 1 is x dash is -4, c1 sine 40, x double dash -16, c1 cosine 40. Let me plug this value over here on my left side. So left hand side is x double dash plus 16s. 16 and x is this one, c1 cosine 40, c1 cosine 40. This will get cancelled out equal to 0. Left hand side equal to right hand side. So this one is a solution. Same way, start with x equal to c2 sine 40 and take the second derivative, first and second derivative, plug it over here on the left side. You must get 0 on right side. So there is a solution. I just leave that second part to you. I solve the first part, second part that is for you. Is it okay? Is it okay?
Yes.
Yes, sir.
Please guys, don't disappoint. It's just the first day. I'm pretty sure after some times, probably after a couple of days, you will enjoy this course. Yeah, this is just the introduction portion. So probably you may face some problem. And I don't blame you. I don't know how you guys are treated in the past. But yeah, this is just the introduction portion. So you need to pay some more attention because right now I am just building up your base for the course. So might be, you may feel that this course might be a hard course or like this. No. Just read this thing twice, spare some time, and hopefully you will be good. And you will enjoy this course after the second chapter or after first chapter. Trust me. Don't disappoint, please. I'm here to help you out every time. Verification. Last example, I will stop. It's just the first day. I don't want to stress you. Right? This is just first day. So I'll stop after 5 minutes, 5-7 minutes. And today I forgot to give you a break because I can see on your faces, including girls, that you guys are looking tired. Think about me. I'm teaching since 7:30 in the morning. Constantly, almost. Yep. So we'll stop after this example. After this example, we'll stop and this x square was messed up. Don't count this blue line, okay? I think I need to. Anyway, y minus x y dash equal to y dot minus x plus s. Y dot means dy by dx. This is the differential equation. This is the example given to you in your practice test again. Y equal to x plus 4 square root of x plus 2. That is the solution of this differential equation. First of all, slightly different theme. This is the differential equation, this is the solution. How to find the solution, I will let you know in chapter 2. But right now, just accept it. This is the solution. First of all, I want to verify this thing, whether this one is a solution or not. Second thing is, I want to verify the domain. What is the domain of this function and domain of this function? I explained to you, domain of this. Domain means, how can you find the domain? I don't know. How you guys, how can you find the domain of the function, guys? Suppose I give you y equal to square root of x. What is the domain?
Isn't it infinity?
Say again?
Yeah. Wouldn't the domain be infinite since it can be any x value?
Any x value? Okay.
Yeah.
If I take x equal to -2, then?
Then it'd be y equals 4.
No. Y equal to square root of x, I said.
Oh, y
Square root of
squared.
x.
Oh, I
And
was
if I
looking
take
at y equals x squared. Oh,
no, y equal to square root of x. Just don't count this one, please.
yeah.
Doesn't it have to always be positive?
Anything above 0.
Anything above 0?
Yes, sir. Because otherwise you get unreal numbers if you're
Who is
trying to.
there? Who is there?
Huh?
Who is there? Harris? Who is answering this question?
Hostetler.
Hosteller. Okay. Hosteller. What's about 0? You are absolutely right, but what's about 0?
Oh, yeah. I guess you would include 0 because square root of 0 is.
Square root of 0 is 0, right?
Oh,
Your domain is, if I write y equal to square root of x, your domain is x is greater than or equal to 0, because domain is the values of x for which your function is well defined. Agree? That if your sum of the numbers which does not define, some of the numbers which don't define your function, you have to remove those numbers from your domain. You have to exclude those numbers from your domain. Agree?
Mm-hmm.
Agree? Okay. Now let's go here. My solution is this one, x plus 4 square root of x plus 2. What is the domain? There should not be any negative number inside the square root sign, because that will give you the complex numbers. And we are working with the real number, real domain. That means my x plus 2 inside the square root sign, it has to be greater than or equal to 0. Means my x is greater than or equal to -2. Agree? And this is just multiplication. This is x. Any x is valid over here. So mainly my domain depends on this part. So my domain of the function is, domain of my f or y is -2 to infinity. Starting from -2, 0 to infinity. That is the domain of the function. Agree? Domain of the solution. Agree?
Yes.
Yes, sir.
Girls, Rodrigues,
Yes,
Yes.
sir.
Margie.
Yeah, I got it.
Margie, what is your major?
I'm biomedical.
Biomedical. Oh, I'm sorry. You told me. I forgot. Okay, good. So y dash equal to, now y dash, I want to verify this thing. Let me divide by y minus x throughout. So y dash equal to y minus x divided by y minus x. This is not y dash, I'm sorry. This is just y minus x. Some printing, sorry, it's just y minus x. So y minus x divided by y minus x plus 8 over y minus x. Means it's 1 plus 8 over y minus x. Plug the value of y, this value of y. So 8 over x plus 4 square root of x plus 2 minus x. This x will get cancelled out. 1 plus 8 by 4 and square root of x, square root of this x plus 2. 4 2s are 8 So 1 plus 2 square root of x plus 2. Right? That is my y dash based on the left-hand side when it's given equation. Now, my solution y equal to x plus 4 square root of x plus 2. Take the derivative of the solution. I'm getting the same thing. So it is verified. There are several ways of verification. I have just used the verification like this over here. Right? Second one, see, I verified like this, but suppose somebody says that, no, I don't like your method. That's fine. Let's go for the other method. Let me start with the left-hand side. Left-hand side is y minus x y dash. And I want to prove my right-hand side. So y minus dash, y dash. Y minus x, y dash. Y minus x as it is, y dash is solution. 1 plus x divided by this one. The numerator, it is negative half. Okay, multiply this one with this one. So y minus x with 1, so y minus x. Plus y minus x with 2 times x plus 2 to the power half. 2 to the power half. Y minus x plus 2 constant, pull it out. This multiplied with this one. Sorry, y minus x plug the value of y. That is this one. Minus x as it is. This is as it is. 2 outside. I just plug the value of y. This will get cancelled out. This will get cancelled out. So y minus x plus 8 square root of x plus 2. 4 to the 8. And this one. This square and this will get cancelled out. So 8 plus this one. Y minus x plus 8. And that is my right hand side. Look at here. Y minus x plus 8. That's the second way of verification. Anyway, your method must be correct. That's it. Otherwise, what way you choose, that's your choice. Oh, it's here. See, I wanted to look at this one. It's here. I didn't want to give you the answer. This is the page. I wanted to show it to you. That's fine. We did this thing. DFQ, this is just the revision. Why DFQ is required. How fast does a disease spread? How fast does a population change? How fast a rate of infection increase or decrease in the population? This type of questions are answered by differential equation, and that is the reason why we learned this differential equation course. And classifications are given like this. Ordinary differential equation means equation contains the only ordinary derivatives of one or more independent variables with respect to single independent variables. That is the ordinary derivative. And this is just the revision, linear differential equation, classification, same example, again, same example, whatever I just took it. Same example, one more example. This is your question number 3. That is based on domain. So I think we can stop over here, and tomorrow we will start with this one, okay? Question number 3. Sounds good? Or if you want, I can continue. It's up to you. I'm waiting for your answer, guys.
All right, see you tomorrow, sir.
I knew that, Harris.
And, sir, Dr. Dimple, just to clarify, we can either do the practice test or that first set of homework, correct?
Correct.
And then you want us to turn those in. Would we do that through email or Canvas? How's that going to work?
Canvas. You have to use the Canvas, because on the day of exam, I'm going to submit one assignment on Canvas, the exam, and after my submission, only you will be able to submit your document. So at the end of the exam, you are supposed to submit 2 documents. One is your exam, second one is your homework. Clear?
All right.
So we turn it in concurrently with the first exam.
Say again?
So we're turning in either the homework or the practice test with our first exam.
Correct.
All right.
Yep.
Good.
And where in Canvas, sir, do we submit that?
Say again?
Where in Canvas do we submit?
Where in
those
Canvas? In the assignment. I will let you know. I will let you know when the time will come. Yes, Margie?
Oh, and another thing is, I had a couple of questions. So we don't need to get the book, right? You'll have those posted online? Or...
Don't ask me this question. Oh my gosh, I'm going to put this video on YouTube. I'm trying, I don't know. Whether I will get succeed or not, I don't know, because some supporting documents, supporting files are required for Zoom recording. But if it will allow me to put this one on YouTube at that time, don't ask me these type of questions. I don't. Yeah, but yeah. Shall we discuss this thing some other time? If you find, see, my simple answer is if you find this book online, that sounds good.
Mhm.
Try to Google it. If you find it, that's fine. Otherwise,
Okay. And does the class meet every day? I never saw, I just got Canvas today because I just registered yesterday, so I'm not sure what times we're meeting. Because I saw your email and then came onto the link, but is it every day during this time?
every day during this time and the same ID and password.
Okay.
Okay. If it is different, check your email. If it is different, but most likely it will be same ID and password.
Okay. And we're supposed
I
to do
provided you, sorry, I provided you 2 IDs. If the second one is not working, in that case, you can try the first one, but most
Okay.
likely the second one will be working now. Okay.
And then, so every day we have the practice problems or homework, and we can do either one, and every day we're supposed to do them. So by the test, we should have like multiple that we have to submit at
Correct.
once. Right?
Correct.
Okay.
Yep. So every day, I'm not going to ask you to submit your homework every day, but I may ask you, show me your homework. So you can just show me like this. Whatever the page is, I show it to you like this. Just show me your homework like this. I may ask you like that, but I will not be asking the hard copy or any kind of submission before the first test.
Okay.
Any other question? Shall we stop here? Yes. Alex.
Yes.
Fiorio, right?
Yes. Can you hear me?
Yeah. I'm sorry. It's hard for me to pronounce your last name. I can say Alex, right?
Yeah, you can say, yeah, that works.
Okay, good. Are you good, Alex?
Yeah, I think I've got everything.
Good. Very nice. Yep. Okay, guys. I'll see you tomorrow at 9:45. Stay happy. Stay safe. And yesterday, I think we had good news, right? That which company, Membro, they found the medicine. The vaccine.
Wait, they developed a vaccine now?
Yeah. US found the vaccine for COVID-19, and they tried 45 infected people, and all of them they recovered in very few days. Yes, and
Oh, wow.
with very minor side effect, like some normal fever or like this. So then there's the reason. Yesterday, everyone were really happy. All the news channels, CNN, Fox, then CNBC, MSBN, everyone, they were just like, bro, we got it.
Wow. That's crazy.
It means everything will open back up.
It's good. Anyway, guys, so take care of yourself. I'll see you tomorrow. Okay. Do you have any more questions, guys? Any more questions?
Nope.
No. Okay, guys.
Have a good day, sir.
Bye.
Have a good day, sir.
Have a good
You
day,
too.
sir.
Thank you. Thank you. See you tomorrow.
So I have a quick question for you, actually.
Why? Go ahead.
I was looking at the homework, and you don't have the like outline posted with the homework for the textbooks. So is the textbook questions part of the practice test?
Practice test is the part of the textbook questions.
So if should I do the practice test rather than the textbook questions?
Both are same actually.
Oh, they're the same exact.
All the practice test problem, they are taken from the book, from article, from your chapters.
So I should work on the practice test. Is that correct?
Yes.
Okay. I think just wanted to
Okay.
confirm that.
No, that's fine.
All right. Thank you. Have a good day.
You too. Thank you. Take care.